Welcome to the second video on transformations. In this video we're going to focus on what happens when we have two or three or four of these numbers placed in the same function. First thing that we need to realize is that we need to get the equation in a certain form. We need to write it so that there's a number that's being multiplied in the front. We need to clearly have a number that's being added or subtracted in the back. And then probably the biggest thing is the things that are going on by x that are inside of the function. So f kind of represents whatever function we're looking at. We need to make sure that the b value gets factored all the way out and that we can clearly see that it's x by itself plus or minus a number. So these are a couple of examples that you might see with sine or an exponential function. But there's really an unlimited number of functions that we could look at, and if we can get it into this form, we can somewhat consistently describe what the graph will look like. So the order that I normally make my changes in once I've put it in the right form is B, H, A, K. We've talked about this before. The biggest thing is that as you list this, you list B before H and you list A before K. So if you do it in a slightly different order, as long as you follow that general rule that B comes before H and A comes before K, I'm happy. So here's a nice complicated slide that kind of describes why the horizontal changes seem to be opposite of what we generally talk about. It's pretty in-depth, and I will save this for class. We may look at it, well, I'm sure we'll touch on it, but I'm not going to go into that in depth right now. So let's look at a few basic examples here. How would you describe the changes that are going to happen if this was your function? So if we were to start with the square root function and want to transform it so it matched all the things that are going on here, well, first the thing we do is make sure it's in the right form, and we see a number being multiplied in front of the square root. We see the 10 being added at the end, and then we see that the -4 is factored apart from the x. So now all I really need to do is go through and list out B, H, A, and K. So B was -4. That tells me to reflect across the y-axis and then do a horizontal shrink by 1/4 or horizontal compression. The big thing is that you list horizontal compression. Whether you make this a 1/4 or a 4, I'm okay with either. And really these two parts could have been flipped around as well. You can do the horizontal compression before the reflection. Okay, your H value was 7, so shift left 7. A is 3, do a vertical stretch by 3, and K is 10, so you go up by 10. This is the order that I typically write it in again, but there can be some slight variations. Okay, this one's a little bit more difficult, still square root, but it's not in the right form. And so we do need to get used to rearranging things so that we can get it into the correct form. So here's one change that you could make. Inside of the square root itself, I want the x part to come first, so I just flip-flop the -2x and the 100 around. And then when I divide by one thing in the denominator, I can divide the individual pieces in the numerator by that one thing. So I'm going to divide the whole square root thing by a 4 and also divide the 8 by a 4. And then really there's just one more step here, I suppose. You're doing several things in that step, but instead of dividing by 4, right here, I'm going to multiply the square root by 1/4 instead. The 8 over 4 becomes the 2, and then this is the thing that we generally forget to do. We need to factor the -2 away from the x. I don't like this right here. I need to write them separately. So the -2 comes out to the front, and when I do that, I'm also taking a -2 from this positive 100. So a lot of changes kind of happening at once there, but that's the general form that we want to be in. So again, now I can list what B is. It's -2. So I'm going to, again, reflect over the y-axis, do a horizontal shrink by 1/2 or by 2, however you prefer to say that. Again, those two things could be flip-flopped. H is -50, so we're going to right by 50. A is 1/4, a vertical shrink by 1/4 or a vertical compression, and then K is 2, so we go up 2. And I believe our last example here, based on a parabola of x squared, we do again want to be a little careful with this. So we want to, I think with square root it's a lot easier to see what is related to the b and the h values. Here it's a little more difficult at times, but you can clearly see that this is the stuff that is inside the squared function. The -2 is not, so this -2 will end up being our a value. Really, the only change that needs to happen here is I need to factor the 4 away from the x. So the 4 has been factored away from the x. I also need to factor a 4 out of the -32. So I get this. So then if you follow the parentheses, from this parenthesis to that parenthesis, that's all being squared. So all of this is related to x somehow, to horizontal movements. The -2 and the 7 are outside of the squared function. They're related to vertical movements. So again, from here we could say that b is 4, horizontal compression by 1/4. H is -8, we're going right by 8. A is -2, so now we're reflecting across the x-axis and do a vertical stretch by 2. Those two pieces could be flip-flopped. And K is 7, you shift up by 7. So I believe that is it for examples. Jot down any questions and answer the questions that are listed here at the end of the video.